Afternoon, everyone.
We are live. Please start.
बावी स्पीकर दाइलू आएगा हाँ लाइव क्लास
Good evening, everyone. My name is Joshi. I will take this.
Good afternoon, sir. You are not audible, sir.
Can you hear me?
Yes, now we can hear.
Okay. Okay. I will be a little bit louder. All right. So as I was saying, my name is Joshi. I will be taking this live session for computational thinking, which is for the preparation purpose of your quiz 3, which is scheduled tomorrow. So today we'll do something different than our usual live sessions. Instead of taking one question at a time, I would prefer to I will try to cover the entire syllabus what we have rather than going into lecture by lecture or question by question basis. I would like to cover major all important concepts and maybe some confusion if there is some confusion. So we will try to address those things with respect to maybe last 3 weeks or if possible maybe even before that. As we have already taken live sessions on activity, practice, graded, and so on. So anyway, even the mock test session also happened yesterday night. So if anyone has missed it, still you can watch it on YouTube. So that's available there. So if you have a question, you raise your hand. I will try to get what kind of confusion you have, and I will try to address it all together. All right, rather than giving time for individual person. Otherwise, we end up answering only few participants' answers. I mean questions, and later on others don't get chance at all. So I will collectively try to address whatever questions you have as. All right. So first, right now, so whoever has a doubt, same thing. You raise your hand, and I will let you talk one by one in that same order. So yeah, first Sunita, go on.
Hello, good evening, sir.
Yeah,
Sir,
good.
I have out from 2 graded assignments, that is week 8 as well as week 9, one question each.
Okay.
So in graded assignment 8, question 4, I have selected, I mean, it's a matrix which they are making out of 2 distinct pair of students who can help each other in at least one subject or there is 2 matrices. One is A, which captures the number of distinct pairs of students who can help each other in at least one subject. And there's another value which is initialized, which captures the number of distinct pair of students where one can help the other in all subjects.
Correct.
So there are 2 different codes which have been given. We have to fill in the code, and there are 2 different codes which have been given. So the correct code they've said is a matrice ij which is greater than 2. When I solved this question, I solved it as equal to 3. So I couldn't understand why that equal to 3 is wrong and greater than 2 is correct.
Okay. Have you referred the solution document what we have released?
Yes, sir, I did, but they've given only the reason why they've selected greater than 2, which I agree, greater than 2 is also correct, but why not equal to 3 is what I want to understand.
Okay, okay. Let me get that question. Just give me a second. Okay. Actually, the issue, I mean, problem is not with that condition. Okay, let me share my screen. Okay, fine. So that's your one question. Otherwise, the second question.
Second question would be from graded assignment 9, week 9, question number 9, sir.
Okay.
In that, there is one PS is equal to DFS APS 5. So I understand that the node which they select is 5 for the DFS programming.
The answer is cannot be determined, and you are wondering
correct.
why.
Yeah, why?
Okay,
Yes, sir.
got
Yes,
it.
sir.
Got
Yeah.
it. Fine. All right. So those two, okay, we'll talk about it. Okay.
Yeah.
So
Yes,
that's
sir.
it from your side, right?
Yeah, that's it from my side, sir.
Okay. Thanks, Anita. Next, Samit, sir.
Yes, sir. I have two doubts. One is
Okay.
week 9,
Mm-hmm.
week 9 graded assignment, question number 6.
Question 6.
Question number 6. They are
Yeah.
returning the players,
Mm-hmm.
and one is inside the square bracket players, and one is normal players. I
Okay.
select
Got
the
it.
normal
Got it.
players.
Got it.
This
Got
is
it. We
one.
will talk about that. Yeah. Next.
Okay, this
Yeah.
is one, and second one is particularly for that graph type of question.
Mm-hmm.
Sometime I get confused whether I
Mm-hmm.
have to make a matrix and put
Mm-hmm.
the age as per question direction, or I will
Mm-hmm.
make the nodes and solve this question. This is where I get confused.
Okay, okay. Any specific question? I mean, so that we can, I can take that as a reference while explaining. I mean,
You can take,
yeah.
means not any specific one, wherever
Mm-hmm.
they are particularly this note type of question.
Whenever the
I
graph
get
is there. Okay, got it.
yes, I
Okay.
get confused ki I should make a matrix. I always try to make the matrix and try to answer the question, but
Okay.
when I saw the solution, I saw ki people are solving through nodes only. This is where I get confused.
Okay, fine. So, all right, fine. So got that. So first, these two, three small queries are anyway there. So let's address this. Then I will go. I will try to cover the syllables from week 7 to 9 first. And if we have a time, we'll go to week 5, 6, and maybe even before that if we are interested. So that's how we will do. In between, if anyone has any question related to the concept, whatever I'm trying to teach, or not, I should not say teach, I mean, try to revise. So you can unmute and we can discuss on it. All right. So we will do that. Let's keep it open discussion kind of. All right. So let me share and first address these two, three small issues. Okay, so okay, as this one is open, so let me address this first, then I will go to that other question which Sunita asked. Okay, so over here, your question is regarding this square bracket, right? So,
Right,
Shamit, yeah. So over
right.
the difference between this and this particular thing is over here we are adding players as a list directly. Okay, I mean we are adding the elements, whereas over here we are adding list inside a list. So over here we are trying to create a nested list. That's why it has to be enclosed in square bracket. I guess that's the correct answer if I am not wrong. Yeah.
Means why that is the correct one? Why not the bottom one?
Okay, because okay, whenever the players itself is a list, correct? When you try
Yeah.
to append, see, ultimately whatever you return will come back to where over here along with this plus plus,
Yes.
correct? Right. So whatever you return from there will ultimately will be used with this plus plus operator. And what plus plus operator do? It can either append to list or it can extend. I mean, plus plus operator can be used in two ways. One is append and the other is extend. If you remember from the lecture, right?
Hmm.
So if you don't put the square brackets, then it will simply merge to lists. And over here, we don't want to merge two lists. As per the given statement, I mean, whatever the problem statement we have here, we want to insert that whole list as a single element inside the original list. Are you getting what I'm saying?
Okay.
Yeah. So that's the difference. We don't want to merge two lists. We want to insert one list inside the other list. For that, we have to put those square brackets.
Achha. Okay.
Okay. Yeah.
Hmm.
So regarding your other question regarding graph, that I will come when I'm trying to explain graph. I mean, anyway, that's what I'm planning to cover. All right.
Okay.
Yeah. Then Sunita, you had some question from week 9 also. Are you there, Sunita?
Yeah, yes, sir. It was question
Okay.
number 9.
9, correct. So over here it says cannot be determined because of this last line over here. Node is equal to keys of P. P is a dictionary, right? And dictionary do not preserve order. So whenever we
Okay.
say keys of P, it will give us all keys from 0 to 5. But we cannot
Okay.
predict in which order that list will be written.
Okay.
The first
Okay.
one, it can be this. I mean, there are many different combinations are possible, right? Where 0 to 5, all numbers are present only once, but the sequence will be different every time.
Okay.
That's why
Okay.
the answer is cannot be determined.
Sir,
This is
if it,
another concept anyway. I'm going to cover in some slides which I'm going to discuss after
okay.
this. So this
Okay.
one anyway will address maybe in some time.
Okay. Fine, sir.
Okay, sure.
Yeah.
And your other question was from week 8.
Question number 4, sir.
Yeah, I think over there you missed something, that there is one more condition outside. See, this is not because of this greater than 3 or this thing. That is fine. There is this particular condition which is required. If I is less than j. Guys, please don't create ruckus. If you are, please keep yourself on mute. Yeah, so Sunita, this particular condition is important, which is missing in that equal to 3. That option
Okay.
is wrong because of this not condition not being there, not because of its equal.
Okay. I understood now, sir. Yeah. I probably didn't observe that.
Yeah. Okay.
Yeah. Yeah. Thanks a
Sure.
lot, sir. Thank you.
Yeah. Thanks. All right. So yeah, still few more hands are raised. Maybe okay. Harshit.
Good evening, sir.
Yeah. Good evening. Tell me.
Sir, I have doubt in activity 9.5, question number 3.
Okay, fine. So see, this particular session is we are going to take in a different way, but fine. I noted your doubt. Okay, next. Do you have any other doubt?
Yes, so I have a doubt here.
Harshit, do you have any other doubt?
No, sir.
Okay,
Just
fine. Sure, thanks. Yeah. Arushi?
Yes, sir. So in the same question, this graded assignment, graded 8, the question this particular question which is on your screen. So if would option A be correct if this condition I is less than J would have been given?
Okay. Let me see remaining conditions also. Yeah, then there will not be any issue. Equal to 3 is fine, because anyway we are saying pair students. Yeah, I mean greater than 2 is anyway equal to 3 only, because we are never going to go beyond 3, because we have only 3 subjects. So yeah, what if you put that condition out, I mean if you put this first if block inside that other condition which says I is less than j, like this one, then it will be done. Okay?
Okay, sir. Thank you.
Yeah, thanks. Yeah, Shreya, what's your
Uh,
doubt?
Hi, sir. Yeah. Same graded assignment 8, question 6. I wanted to understand difference between option A and option
Option, question number 6.
6. Yeah.
Okay. This is something where there was a bit of a typo. So this is something we discussed and uh, okay. So what actually we were trying to say is a book with both I and J, and over
Right.
here you read it as at least a book.
Okay. So
Okay,
I
so
chose
that
option.
that was missing. I mean, this is something we discussed many times in many live sessions earlier.
Okay, I'm sorry, I missed that, I think.
Yeah, no, that's fine. That's fine. Just read it as a book. Okay.
So why is that wrong? Like, why is option C incorrect?
Because we don't want at least a book. We just say, when we say at least, that means more than one book is also possible. That's what this option says.
Correct. But isn't that what the return? Like the code can, like there could be authors who have authored more than one, right? But we are
Correct.
counting them only as one. So isn't that what is the output of the code?
No. So I don't know whether you were there part of this discussion, but this is something which we have discussed. I don't even remember how many times we have discussed this
Okay.
question. So
Can I
yeah.
refer to any of the live videos? I'll be able to
Yeah.
find.
Okay. So this is week 8 graded assignment, right?
Yeah.
So week 8 graded assignment, that solve with instructors thing we have, right? So you can
Okay.
refer that, or the open session for week 8 also you can refer.
Sure.
So
I'll go back.
if you refer any week 8 live session, this question will definitely be there.
Okay. Sure.
Okay?
I'll do.
Yeah,
Thank
sure.
you.
Thanks. Yeah.
Excuse me, sir. I have
Shreyansh?
in same question. Can I ask?
Yeah, sure. Tell me.
Sir, actually, I'm not able to understand how this code is working. Like the step by step, I'm not understanding.
Okay,
It
fine.
is for each loop only.
Yeah, so for that, I would suggest that please can you do one thing? Can you refer the solution document which we have released? Because today, see, this is the preparation for quiz 3, not like explaining one question at a time. This question is not going to come there for quiz 3. So today, the plan is to cover the entire syllabus of quiz 3. So I want to move towards that side rather than explaining one question at a time. Okay. So
Okay,
you
sir.
please
Sir, just
refer
one
the
thing, if you can
see,
clear,
anyway,
just
it's
one
week
thing
8.
regarding this question.
Yeah, tell me.
Sir, the like we are creating a matrix, right?
Mm-hmm. Yeah.
And each element of that matrix, like m of 0, 0, is also a matrix.
No. How it will be a matrix?
Here it is like it is written for each I in in keys of book.
Hmm.
Then we are taking keys for like values of those books, authors.
Hmm.
So is
Correct.
it something like that?
No. I think this create matrix, this particular thing you remember how this create matrix procedure is written, which is explained by the lecture by
Yeah,
Professor
yes, sir.
Madhav.
This I remember, but after this
Yeah.
for each loop.
Correct. So using this for each loop, we are simply modifying the values or appending some values into it. We are not creating another matrix inside. See, ultimately, matrix is what? It's a dictionary, right? Do you see any other new dictionary being getting created anywhere apart from this? Only this
No.
line will create that, right? Below the, apart from that, we are only changing values for JK, KJ, and so on, whatever it is. We are just simply changing value. We are not creating any new dictionary or any new matrix as such over there.
Okay,
Yeah.
sir.
Yeah.
Okay, thank you, sir.
Yeah. Shreyansh?
Yeah, my question is from week 6. If that's
Mhm.
okay, I can ask.
No, you mentioned your question. I'm just collecting questions. Then I will go to. I will try to cover the concepts rather than specific question explanation. So,
Yeah,
yeah,
correct.
go ahead.
So I have a small difficulty key when it comes to keys.
Mm-hmm.
So if you can explain the concept of keys a bit, because when it comes to
Sure. That anyway I'm planning to do.
okay, that's it.
Okay, sure. Sachin?
Sir, I had a doubt in the mock test question number 5. If you can describe why the option B is not
Can
correct
you
there.
refer? Can you refer the solution document or yesterday's live session? The entire live
Sir,
session was dedicated for those some 5, 6, 7 questions, whatever we have.
okay, sir.
And also the document is also available over there, so you can refer the solution document also for that purpose.
Sure, sir.
Sure. Yesterday night, you can get that YouTube link 9 to 10:30 yesterday night. Okay?
Can you please explain depth first search and breadth first search? And
Sure. That's yeah. Okay. Any other concepts you want me to cover? So that's what actually I was like, hoping that tell me some concepts which are confusing for you, rather than specific focusing on one question. Definitely, whatever questions you have seen so far in activity, practice, graded, you all know that they are not going to get repeated in tomorrow's exam. Okay, tomorrow exam you will see new questions. So in order to solve new questions, you should have your concepts clear. So that's the plan for today's session. So if you have any conceptual doubt, will just let me know. I will try to cover that.
Excuse me, sir. Can I say something?
Yeah, Pragya, go on.
Sir, actually, I have doubt in like in variable names, like in the lectures also. I mean the variable names and how we assess keys, values, like all these things are in my understanding. I mean, I get confused, like about what thing this is asking about. So please
Okay.
clear those concepts, like which variable and saying to I mean what value we have to assess and all these things.
Okay, fine.
Means these are confusing to me.
Sure.
सुमित सर सर वीक 8 के जो कॉन्सेप्ट्स हैं वो एक बार शॉर्ट में आप डिस्कस कर दीजिएगा जो वीक 8 में डिस्कस किए गए थे
Yeah, we'll talk about weekend. Yeah.
Okay, thank you.
Okay, sure. Harshit, you raised your hand. Any specific?
Yes, sir.
Yeah.
Sir, yes, sir. As we know, what is the work of init? But
What is
I
the
want to know work of
init?
init.
Init. Okay.
Yes,
Return type of init.
Yes, sir. Then what is the work of init under init?
What is init inside init?
Yes, sir.
Okay, sure, fine. So anyway, that's something I'm planning
Explain
to
all
cover.
the functions of list. That is rest in it, both of them.
Done. Okay, done. Yeah, that's on my agenda. Next.
हे फालतू प्रॉब्लेम आहे
What?
ज्यांनी ज्यांनी काय सांगितलं ते मला नाही माहित.
Please, guys, if you are not talking here, keep yourself on mute.
Yeah, hi sir,
Okay.
this is Neeraj.
Yeah, Neeraj.
Yeah, sir, I am interested in knowing the use cases or for BFS and DFS and what in which situation we should use what algorithm and why we should prefer one algorithm over the other, like BFS over
Okay.
DFS or DFS over BFS.
Okay, sure. You are talking about applications of BFS, DFS. Actually, we are not. I mean, that much part is not required in this syllabus. That is something which is out of the scope of computational thinking. But fine, we will try to address that also. Right now, you don't have to think too much about that. But all right, fine.
No, I'm asking because in the graded assignment as well, I believe there are some questions where has been asked for the shortest path, which algorithm we should use, or some questions like that. So at least some pros and cons to use algorithm, like what is the benefit of using DFS or BFS. Okay, sir. Thank you.
Sure. Anyway, if you remember in our syllabus, we have covered only DFS. BFS is not there. They just mention it once somewhere. The professors mention it somewhere. But apart, I mean, there might be one or two activity questions also. But if you look at the syllabus structure, all lectures are related to DFS, not a BFS. Okay, there is not even a single lecture or tutorial based on BFS. Okay, so focus more on DFS because DFS is something which we have used to explain recursion. So actually week 9, I mean the syllables may look like DFS, but the purpose behind week 9 was recursion. Okay, and recursion is covered using the concept which is DFS. So your focus should be on recursion rather than DFS or a BFS. So if you understand how recursion works, that's good enough. Don't worry about DFS and BFS. DFS and BFS is anyway, these are data structure concept. Those will come in detail in upcoming courses. In semester 3, you have one course called PDSA, where anyway you will see all these concepts to the minute level of it. Okay? Fine. So any more? I will just another two. Listen. Another 2 minutes. I will hear your questions. Then I will start covering concepts from first. I will try to go backward. I will start from week 9 and I will try to go as back as possible till week 1.
Sir, mock test solution, where it is loaded?
It's there in the assignment at the top. You open the mock test, at the top you will find a link for a solution. Yeah. Guys, please keep yourself on mute. Sandeep, don't make me point you by your name, okay? Keep yourself on mute if you are not talking. Don't disturb others.
Sir, I have some doubts in week 8 Sudoku solve.
Week 8 pseudocodes. Okay, fine. Got it. Shwet. Safwan, what's your question? Safwan? All right. Next, Deepak.
Hello.
Yeah,
So can you hear me?
Deepak.
Okay. So,
Yeah,
my
yeah.
question is like from the concept of BFS and DFS. So like I wanted to know recursion. I mean the process of recursion in BFS and DFS. Thank you, sir.
That's what I just explained. Don't worry about BFS and DFS. If you understand how recursion works, that's more than enough. Okay. So
Sir,
anyway,
can you hear
that
me?
I am going to cover. That's the first thing I will start with.
Okay, sir.
Yeah.
Sir, can you hear me? Hello?
Okay, sir.
Yeah. Okay, sure. Yeah, I can hear you. Tell me.
So this is Afwan. So I have a doubt in rest of init of L.
Mm-hmm.
So let us suppose we have a list that contains one element.
Listen, Safwan, I got it. You have questions regarding list functions, right? We will talk about list functions.
Okay, sir.
Okay, yeah. Varsha?
Just one more question, sir. Like,
Hi, sir.
can I please share the YouTube link? That's not direct, but like, if anything we want, like, YouTube link is not uploaded.
YouTube link for what?
This live stream, you want to fast forward it or somewhere we want to go like what you want said earlier, like.
Okay, you want a YouTube link for this session, right? It
Yeah,
will be
yeah.
available. It will be available there, right? In your calendar. Where you see links, it should be available there.
Actually, it is not uploaded. Only the session is YouTube. YouTube is there. Link is not there.
Let me clarify. I think you're missing something. The link is there in the live session calendar. You'll find it in the portal, not the Google Calendar.
Okay, so that's there. Next, who else is there? Yeah, Varsha, you are saying something.
Yeah, sir. Hi. So there is only one basic question I have. I have this doubt in exit loops from very beginning. So there's
Okay.
this one activity question in
No,
week 7.
Varsha, that's fine. I got the exit loop. You have a question. I mean, I am going to cover that concept.
Cool, thanks.
Yeah. Okay. Is as I have compiled few common concepts, so I'm just trying to get a feel. If I'm missing on something, then I can focus on that. Okay. So this is anyway I'm covering. Anything, Tejaswini? Tejaswini, you have any question? Okay, Apul.
Sir, recursion, but what is the best approach to solve on papers? How do we,
How you solve recursion on paper? Okay,
on papers, what is the best practice?
Okay, okay.
Thank you.
Yeah, Swapnil.
I had doubts on the order of parent keys and the child keys.
Order of?
Parent elements and the child elements, like which you find in the list, right? That thing.
I mean, we don't have any specific concept called parent and child element. We may have used those as a variable name somewhere, but okay, fine. With respect to tree, we will talk about parent and child. Okay.
Thank you.
All right. So let me try. Now we'll go week by week. So right now we will start with week 9. And if you have any questions from week 9, we'll discuss those. Then we'll go to week 8, then week 7, and so on. We'll go week by week in a backward week. All right. So I will share one PPT. Anyway, it's released. By the way, whatever documents I am going to use today, they are already there as a content in week 12. It's not something I'm using new. It's if you look at week 12 content, we have released some content from previous weeks only. So that's something I'm going to refer today. So even though it says week 12, I would suggest you should go through it before your quiz. It will be definitely helpful, even though it says week 12. So is it visible?
Yes, it is visible, sir.
All right. So first, I mean, this is what I'm trying to cover from week 12. Week 12, the major concept, as I was saying earlier, is recursion. Depth first search is just one example which uses this concept of recursion. Okay, so our major focus should be on how recursion is used in programming languages. All right. So we will start with recursion and we'll see how it goes. So why recursion? I mean, in general, first, what is recursion? When a procedure calls itself, then it's called recursion. As in, you have a procedure definition. In that procedure definition, you are calling the procedure again. That's the basic idea behind recursion. Okay. As again, all problems cannot be converted to recursion if any problem which has a base condition, as in something is going on, and at some point, okay, some condition has reached. At that point, you should stop. If you have that fixed stopping condition, that's something called as base condition, then only those kind of problems can be converted to recursion. Okay, so for example, your factorial, you keep multiplying factorial of, let's say, some, anyway, that's the example I will take in the next slide. So that will take recursion simplifies the pseudocode. All right, fine. So consider this particular pseudocode procedure. Okay, what we are trying to do here, we are trying to calculate, find a factorial. But over here, if you look, there is just this factorial procedure. Inside, you will not see any call to this procedure. This is not a recursive procedure. This is a normal procedure which you have been seeing for last some 6-7 weeks now. So just plain procedure. You pass n as a number. We will have factorial as initially 1, and we are just simply multiplying factorial equal to n every time n gets decremented by 1. So if you pass n as 5, it will do fact as in 1 into 5. Next time that result 1 into 5 will go into here in the fact, so it will become 5. Next time value of n becomes 4. So next time it does 5 into 4, then it do that again multiplied by 3, 2, 1 until its n is greater than 0. So that's the general idea of a factorial, right? But now we have to convert this particular procedure into its equivalent procedure which has a recursion. So that is done something like this. If you try to compare the existing procedure with the procedure with recursion, you will see there is hardly any difference. Okay. Initially, over here we assigned factorial equal to 1. Why? Because that is a base condition. So same thing, that base condition is converted like this. If it is equal to 0, we are returning 1. And this particular while loop got converted into this particular recursive call. Still we are doing same. What we were doing here? Factorial into n. We are still doing that. N into, now instead of over here, n was getting reduced by n minus 1. We are doing same thing. Factorial of n minus 1. So if you see the transition wise, I mean the conversion from plain procedure to a procedure with recursion is there is a little bit only variation. Otherwise, the majority of code stays as it is. Okay. So now we'll take this particular example of a factorial.
But sir,
yeah.
But sir, in here the left hand side procedure, the all the values is stored under the variable fact. But
yeah.
In the right hand side, where this value gets stored?
Where we are not storing it. So let me come to that point. Okay. Let me finish this, then I will take recursion questions. Okay.
Okay.
Okay. I mean, I will stop after every concept and I will take questions. Okay. Let me complete it first from my side. Okay. So we'll take this particular example, and right now it just n. We will pass some parameter specific value to it, and then we'll see how actually the execution works. So this is that same procedure what we are discussing. But right now, let's execute this procedure with specific value for n, which is, let's consider 5. Okay. So everywhere there is a n, we replaced n with 5. That's how procedure will execute. All right. So in this case, what happens? You start your procedure execution. You check if 5, earlier it says n equal to 0, but now value of n is 5. So ultimately, how computer will check? Computer will check whether 5 is equal to 0 or not. Now, as you know, 5 is not equal to 0. So if block will not execute, it will execute else block. In else, what happens? Return 5 into factorial of 5 minus 1. Why? Because we were doing factorial of n minus 1. So n minus 1 got converted to 5 minus 1. Now, what does this particular thing will do? This part. What this part will do? It will call this factorial procedure once again with the updated value. Initially, right now we call factorial with 5. Now we will call factorial with 5 minus 1. That is 4. So it will generate another procedure call which will look something like this. Procedure, factorial, everything is same, but instead of 5, now we are called same procedure with 4 as a parameter. So this particular part triggered this whole thing. All right. So this particular procedure is not yet, execution is not yet finished. When this particular execution will finish? When we return it. Whenever we return something, then only the procedure will finish its execution. But right now we cannot return. When we will be able to return? When we compute this particular thing. And in order to compute this, we require this value. Who is going to give us this value? This procedure's return statement. So this procedure's return statement will return some value here. Then it will get multiplied by 5. Then only it can return back. All right. So so we have to execute this procedure first in order to get this value. But again, if you come over here and check in this particular red colored procedure, still 4 is not equal to 0. So we'll execute else. In else, again, we cannot return this because in order to return this, we have to do this computation 4 into this part. Again, this part, we don't know what is the answer of this. How we will get an answer of this? When we execute this procedure factorial once again with 4 minus 1, which will trigger next procedure call with 3 as a value. Still, this procedure is waiting for its answer. This procedure is also waiting for its answer. Which answer? This answer. This answer. Now, in order to get those answers, we have to execute this. Over here again, 3 is not equal to 0. We will execute else. Again, we want answer of this particular question. What is the value of factorial of 3 minus 1? Unless and until we get that, we cannot execute this particular statement. And if we cannot execute this, we cannot return. So this particular part, factorial of 3 minus 1, this will trigger next procedure call with 3 minus 1, which is 2. So it will come like this. Similarly, again, we cannot return. We have to get the value of this. So this will trigger next procedure call, factorial of 1. Once again, if you check over here, if 1 is equal to 0, it's still not the case. So we cannot return 1. Else, we have to execute this. Over here, factorial of 1 minus 1. It will trigger this procedure once again. So now, this is the place where our recursion stops. As in, the calling part stops. Returning part will start from this point. Now we have we first called this one called, this one called this second one, that called this, then this called this, then this, and finally we have reached this point where nothing new has to be called. Why? Because this else block will never execute. I mean, this particular 0 minus 1 may look incorrect, but programmatically there is nothing wrong, because else block will never execute. Because this, if 0 is equal to 0, it will return 1. So where it will return 1? It says return 1. Whenever we say return 1, what does that mean? You are giving something back to somewhere else. So where that else is? So that's something you have to understand how return statement works. Return always returns to its call. Okay. Why? I mean, what triggered execution of this particular block? Why from where we started this? Because of this line. Because of this factorial of 1 minus 1, this red color pseudocode started its execution. Okay, so who triggered this pseudocode execution? This particular highlighted line over here. This particular highlighted line triggered the execution of this red part. So this return statement should return to this particular line. All right. So because of that, what will happen? It will return 1 where? Over here. So this particular highlighted part should be replaced by this 1. That's how the execution will work. All right. So this particular red part executed and it returned 1 where it was called. Now we can return 1 into 1. That now can be calculated. Now we are not waiting for someone else to give some answer. Now we can computer can simply do 1 into 1, which is 2. Now again we say return 1. No, not 2. Sorry, my bad. 1 into 1, 1. Okay, so we are returning 1 from here again. Where it should return? Same logic. Who called this procedure? That's the place it should return. So it should return over here. Because factorial of 2 minus 1, this particular part, because of this particular part, this procedure execution started. So we'll return back over here. Now again we can calculate this. 2 into 1 can be calculated, which is 2. Where it will return? Where it will return? The place which triggered the execution of this procedure, which is this one. So this is the place where this is the place where we should replace this 2 into 1 answer. Now we came here, return 3 into 2. Same thing will happen. This result 6 will go back over here. Similarly, 6 into 4 will go back over here. And finally, this is the place where we will get that answer 24 into 5, 120, and it will return back where this factorial procedure was called initially with value 5. So there must be some code somewhere, some pseudocode which says factorial in bracket 5. So okay, now let me just highlight something and write over here so that can you see this particular chat window I have opened? This particular
Yes, sir, we can see it.
all right. So there will be some procedure call where it says fact is equal to factorial of 5. So this particular part, so this return right here, right? So this return will return to this part. Factorial of 5. This procedure call initiated this particular blue colored pseudocode. So this 24 into 5, 120 will be returned and stored back to this variable fact. That's how this recursion works. So recursion has two parts. First, you keep calling. At some point, your calling finishes. Then you start your returning back to the original first call of it. That's how generally recursion works. If you look at depth first search, it's still same. I mean, we'll go to depth first search next. But in depth first search also we do same thing. We go def. Some point we stuck. Then we go back and we backtrack. So this is general concept of recursion. So now if you have any questions on recursion, I will take those questions.
Yeah, Omkar sir, this is not a question, just a helpful hint probably.
Sure.
See, I think a lot of people, I mean, I'm quite familiar with the languages. So I know we don't want to call into calling conventions, but I think people get confused when they see a return statement. They think that the entire thing will happen together. So if they think that start from the right side, right, and that will how it will happen, right? So in this factorial example, return n star factorial n minus n minus 1 will happen first.
Your voice is breaking.
That way, I think may be more helpful for them to figure out the recursion.
Sure. Okay. Yeah, so that's what I was trying to. I was trying to demonstrate that only using this.
Yes, sir. You said that. I'm just trying to say that I think people start from the left always, right? They should start from the right.
Correct. Yeah. All right. Anyone else has any question on recursion?
Regarding recursion, a recursive algorithm does not solve the base condition directly. This will be true or false, like.
It can solve it directly if it depends on the input value. Okay. For example, let's consider the pseudocode which originally we started with. Okay. This was the pseudocode, right?
You are saying that input 0, like it will be.
Yes, correct. Then it will directly execute base condition, right?
Okay.
Yeah.
Got it.
Okay. Any other recursion question?
What is the base condition here? Means the minimum value.
See, base condition is the condition where something changes from the regular procedure call. I mean, with respect to depth first search, with respect to recursion, what is the general thing? N into n minus 1 into n minus 2 into n minus 3 into n minus 4 till we reach the 0. Correct? So that 0 is the place where we stop this n into n minus 1 into this particular series is happening, right? The series stops at 0. So that 0 should reflect in your base condition. Something which stops the general execution flow should be reflected as a base condition. Like
can I ask a question, sir? Can I ask a question, sir?
Yeah. Go on.
Sir, first of all, thank you very much. This was the best explanation on recursion, and I had watched all your videos on week
Yeah.
12,
Yeah.
which were very useful.
Yeah.
Sir, the example that you gave on recursion just now, if I were to apply it to question 6 of the mock test yesterday, I'm not able to go the reverse way. So
Okay.
say for example, this do something 190 to 0. So it will do 192 by 10 or and mod 190 to 10. Then it will return the value 19.2. So it will call another procedure called DS 19.2. Am I
Okay.
right, sir?
See, I don't remember the question. Let me recall first.
It
Can
was
you
a very
tell
good
me the question?
question. Question number 6, sir. Question number 6, sir.
It
Of
has some similar kind of calculation was happening with it,
similar
right?
kind of calculation, and then it kind of
Sir, can I explain, sir, that question?
Yeah, see, that question's answer is anyway available at the top. There is a solution PDF which has the answer of that question. So it's not about the answer; it's about the concept how recursion works.
Yes, sir, I am
So
explaining. Actually, most of the students don't understand what the concept is.
correct. So that's what I'm trying to do now. Okay, you want to add anything to recursion? Go on.
Sir, I am not want to add anything to recursion. I am adding point out the concept of the question, because in question there is instruction given that the n upon 10, but that means if I divide n by 10, I have to take remainder out, then the quotient of n upon 10.
Correct. So
Yes.
there are two aspects of aspects are there. One is the division operator, which is your forward slash, which will take only the integer part of it. So if you divide 10
quotient
by
it will
4,
take. Yeah.
Yeah,
it
that
will
means
take
first
only the quotient. Yeah.
that means first it remove the remainder, or that means subtract the remainder, that it takes or gives the quotient. Okay.
Correct. And that mod will give you
That
the
concept
remainder.
many of students that concept don't get.
Okay. I guess regarding that question, you can maybe make it up.
Excuse me, sir. I had a
Yeah.
doubt. Yeah. Good evening, sir. It's Pritodip here.
Yeah, Pritodip.
Sir, I wanted to ask about the general structure of the pseudocode of recursion. Do they always have to contain this if-else loops, recursive
Uh,
procedures?
recursive procedure if else loops. Actually, if else is not a loop, but there has to be some if condition which stops the recursion. Otherwise, what will happen? It will become a never ending thing.
Right. Yeah.
If
We'll
I
never
don't
reach the
have
base
it,
case.
yes, we have to reach to base case, then only your execution will stop. Otherwise, it becomes a never ending thing. You just keep calling, and something which is we generally in programming refer it as a infinite loop.
Okay. Okay, sir. Thank you.
So that should not
Just
happen.
to add, sir, if
Sir,
condition
yeah,
is definitely needed. Maybe a else may or may not be needed, but if condition is definitely needed.
correct. If
Okay.
condition is
Thank you.
needed, the condition which stops the loop, that condition has to be there. Else, it depends on the purpose. I mean, what is the problem statement you have to try to solve. Correct. Okay. So if the recursion is done, shall we? Yeah.
Sir, can I
Sir, I
ask
have a
one
doubt.
question?
Yeah.
Sir,
Go
I'm
on.
having
Is it?
problem with clicks.
Because the questions like should we approach like how should we approach like for solving the question on paper, because when programmatically it like it will run okay, but like when we are solving sometime we are encountered like with technical terms से head or tail हो सकता है, फिर मतलब कई recursion हो सकते हैं, multiple recursion हो सकते हैं एक ही जगह,
Yeah.
तो वो solve कैसे किया जाए जल्दी, मतलब that was I want
Construct a tree out of it. Construct a hierarchy like what I did. So okay. For example, if you are trying to solve this factorial question on using pen and paper, all right?
yeah.
How you will do it? You will construct this particular thing. Yeah, you will have this as an initial code, right? So you will write your top.
We can't see the screen, I think.
Yeah, it's coming. Can you see it?
Yes, sir, we can.
Oh,
Now we can
good.
Yes, sir.
So, okay. So in this case, what you're supposed to do is get that initial, what was that your n was equal to n was equal to 5, right? So you generated your factorial logic. How it was written? N into factorial of n minus 1. That's how it was written, right? So you create a tree out of it. So n into factorial of n minus 1. How you will write it? 5 into, and just for shortening it, I will write just fact. Okay, consider this is that procedure call. So it says factorial of 4. Now what factorial of 4 has? It has two parts. 4 into fact of 3. Now this again has two parts. 3 into fact of 2. This again has two parts. So at this point, what will happen? This was someone is Manjusha Kulkarni, can you please keep yourself on mute? This is third time I am muting you. If you keep doing it, I will have to remove you from the meeting. Please keep it take it seriously. Okay, so over here, this is how you build a tree out of it. So this fact of z, it will give you, this will give you answer 0. So you combine it 1 in, sorry, not 0, it will give you 1. So 1 into 1, you take here. Okay, so take you 1 into 2, take here, take here, take here, and finally your answer you will get 120. So instead of writing the whole code, build a tree out of it. That how you, this is your first call. This was your first call over here. This triggered your second call, third call, fourth call, fifth call, and each call returns back to its previous call. So that's how you should do. This is, I mean, if you look at it, it's just like a depth first search. You keep going in a depth, and you went back doing your backtracking process.
Multiple
Alright,
multiple recursion, like factorial n into factorial n minus 1, and the after that also there is one more factorial, or either we are printing some sort of factorial. Okay, so like how to approach that one thing?
Then in that case, you for your tree, right, you can have tree can have three things. So I mean, with factorial, that's not possible. With list, I mean, some questions are there, right, where you have a first plus plus something, and I mean, you have something like first plus plus, and over here you have a recursion block, and then plus plus last, something like you have, right? I think you are referring to that. If I assume, if that's the case, in this case, right, you divide this particular tree into three parts. Here you will have some number x, here you will have some number y, whereas over here you will have a procedure call, that recursive call. Again, that recursive call will get divided into three. Here you will have some ABC, here you will have a recursive call, and that again you divide in three. So depending on how many variables you have, if you have a recursive call, that recursive call will also only get split. Whatever other things, whatever these variables which are some constants you have, those keep it at that level itself. Same thing what we did over here also. Only that recursive call of fact of 4 got divided, 3 got divided, but whereas this 5, 4, 3, we never did anything to those. So that's how you should do. Whatever recursive call is there, get the sub tree out of it. All right. This is how you should address recursive procedure calls. Fine. Any more recursive questions, or shall we move to DFS?
No, sir. Great explanation. I think this should solve almost everybody's problem.
Correct. Yeah, that's what I mean. Even I think so. Maybe put more attention. I mean, do some more practice on it so that you will get what I'm trying to say here. All right. So we'll move to DFS. Try to share. All right. So this is we've done. Okay, depth first search. In depth first search, again, I am not going into pseudocode because pseudocode of depth first search is something anyway. It's there in the lecture. I want to cover actually how it works. So that part I will try to cover rather than the pseudocode. Pseudocode is anyway Madhavan sir has done it, so there is no point repeating same thing. So let's take this. This is very straightforward and a simple example of one graph over here. By the way, whenever we say depth first search, okay, one thing you should remember all the time is input to a depth first search is always a graph. Okay, let me repeat. Input to a depth first search algorithm is always a graph, whereas output of a depth first search is always a tree. Okay, output of depth first search algorithm is always a tree. Now, what is the difference between graph and tree? There are no cycles in tree. There is no back edge. I mean, that's something anyway visually you can see, but that's what it is. So we'll start this particular. We'll take this example. We'll go it node by node. Then we'll see how the different representation of a tree and a graph looks like.
Sir, repeat what you said. The input is always graph and the output is always a tree.
Correct.
Here, graph means in matrix form or in nodal form?
It's a graph. It will be in the form of a dictionary. Okay. All right. So Pritodip, right? Was it Pritodip?
No, Shomit.
Shomit. Yeah, Shomit. So Shomit, the thing is, after this DFS, I am going back to week 7 and 8. Okay. Over there, I will talk about this node-based graphical structure, matrix, and dictionary, and relation among all three. Okay. So that's anyway my next point. So that time
actually, sir, if you remember, I have my second question, the doubt regarding the solution of this nodal.
I remember. So that's something I have in mind. I will address it when I will cover week 7 and 8.
Okay.
Okay, because that is something comes under graphs, not recursion, right?
Okay.
Yeah, so I will do that, don't worry. So let's do this DFS first. Consider we have this particular graph over here with 5 vertices and these many edges what we have here. Your input starting vertex, we have assumed that starting vertex is 1. So we started with it. Now, whenever we say our starting vertex is 1, that means only 1 is a visited node. Remaining are unvisited. We don't even know how many vertices are there in the particular graph. Computer doesn't know. Computer right now only knows there is one node called 1. So it created a root node for a tree called 1. Beyond that, computer doesn't know anything at this point. Now, what computer will do? As in computer algorithm, I'm just using different terms, but it's same thing. The depth first algorithm, depth first search algorithm will do. It will try to find all the neighbors of node 1. Now, how it will come to know how many neighbors one has based on the matrix or a dictionary which is used to represent this particular graph. Okay, so that's something anyway will come to those technical details that how computer will come to know. For now, you just consider that somehow computer will come to know that one has two neighbors, 2 and 4. So that's the next computation happen. What new thing we learned, that one has two neighbors, 2 and 4. Now we have to take a choice which one to select next. Either we can select 2 or we can select 4. But as we are following one standard standard selection criteria which is ascending order, so in that case we will select 2 first. So whenever we select 2, what does that mean? There should be one sub node or a child node which has to be created under 1. Why? Because we are going to select 2 after 1. So that after part has to be represented somehow. That's why that 2 is added below 1. That means we started from 1 and after 1 we are supposed to go to 2. Okay, so that's why that hierarchical structure is there. That 1 is there, after that there is 2. Now we know that we are at 2. Beyond that we know nothing. We have to find what all neighbors this particular vertex 2 has. Now 2 has 2 neighbors, 3 and 5. Again we'll apply that same logic and choose the smaller one. So we decided to choose 3. So after 2, we are going to visit or we are going to select 3. So 3 should be added somewhere over here below 2. So with 3 got added. But now this is the point. I mean, as per our general logic, what we are supposed to do? We are supposed to find all the neighbors of 3. But now, if you look over here, 3 doesn't have any neighbors other than 2. But 2 is already visited. You can't have 2 again over here. 2 is already above. I mean, if something is already visited, you are not supposed to visit it again. That's the difference between graph and a tree. In tree, if something is visited, you can't visit that again. Okay. So in that case, 3 doesn't have anything. From 3 onwards, you can't go anything. There is nothing after 3. So at this point, we have to go back. Now we have to check, is there anything after 2 other than 3? That's what we have to do. Something that particular thing is called that particular thing is referred as backtracking. We backtrack from 3 to 2 because from 3 there is nothing further. This is like a dead end. When you reach a dead end, what you do? You go back. Okay, this is like on any road. It's called a path only. Your path got stuck here. Somewhere you are driving in some new place. You went in a lane. The lane it's a dead end. What you take? You take a reverse and you go back. Same thing. You go back to 2. Now at 2 we again have to see, is there any other possibility other than 3? So in that case 2. So 2 has one more possibility other than 3, 5. If you remember earlier, it has 2 possibilities. We decided 3, but 5 was something we left behind. So now we can explore that 5 possibility. So in this case, the 5 possibility got explored. Now we are at 5. So from 5, we have to explore what all possibilities are there after 5. So from after 5, there are only 2 possibilities. I mean, if you look over the graph, 2 and 4. But 2 is anyway visited earlier. So only one remaining possibility is 4. So we explored that 4. When we explored 4, now we have to, as per our logic, we have to check what is the possibilities after 4. After 4, there is no possibility because all the vertices are already visited. There is not even a single node which is not visited. If everything is visited, everything is explored, that means this is the place where we stop. And this is the place where our depth first search algorithm stops. This becomes our best condition for depth first search. All nodes are visited, all vertices are visited. In general, whatever vertices were there in graph, once all those vertices are added in the tree, that's the place where we stop. So that is the best condition for depth first search. We stop when all vertices are added.
Sir, can I ask one doubt, sir?
No, just let me finish. Give me another 30 seconds, okay? So that's the place where we stop, and this is our output tree. So that's what I was referring to. Input is always a graph and output is always a tree. So input is a graph, output is a depth first search tree. Now a difference between graph and tree is only there is see number of vertices all are there. Earlier there were 5, here also we have 5. Number of edges will be less or equal depending on how graph is. So number of edges in a tree will always be equal or less than the graph. That's one. And second, there will not be any cycle or back edge. You cannot have edge from 5 to 1 or from 4 to 1, 4 to 2. Those edges are not allowed. You have to go from 1 to 2, 2 to 3 and 5, and from 5 to 4. So you have to follow that specific path like this. From 1 to 2, 2 to 5, 5 to 4. There is a strict path. That's the only way you can reach to 4. But over here, from 1 you can directly reach to 4. From 1 to 2, 2 to 5, 5 to 4. So how to reach from 1 to 4 with respect to graph? There are two ways. One is a direct, one with these two intermediary things. But tree has a specific path. There is only one way you can reach from 1 to 4. 1 to 2, 2 to 5, 5 to 4. So this removes all this complications of cycles and back edges and all those things. So that's the difference between graph and a tree. Here there is a strict thing. This came first, this came second, then these things came, and then these things come. So that levels are there. In graph, that's not there. After 1, you can't say 2 came first or 4 came first. There is nothing like that. Over here, there is a strict distinction. All right. So that's a general idea behind depth first search. Okay. Yeah. Someone was asking a question.
Can I ask a question, sir? I think this is a good explanation that we got. By convention, we'll always go in ascending order when we are visiting the other node. That assumption we should make for the in the test also, right? I mean that's a normal convention. We can take it
unless and until specified otherwise. That's what you will.
Okay, fine. Now the second point very quickly. The tree here actually kind of describes the graph that we have, except for one relationship that one has with 4. But just because one was the starting point, it was already visited. That's why we are not going back from 4 to 1 or whatever. But but that is fine. Or is there any other way to show this relationship between 4 and 1, or that is not required at all in the DFS?
In the DFS, that's not required. That's the difference between a tree and a graph. See, whatever relations were there in the graph, all relations will not be represented in a tree. So tree will not give you, the entire picture of the graph. So from tree, you can't go to graph. But from graph, you can come to the tree. Tree is nothing but a subset of a graph.
Got it. Thank you. Thank you very much.
Yeah. Okay.
I have a question.
Yeah.
How we can find there is a S between two nodes or not in DFS tree?
Sorry, can you repeat?
Sir, how would we find that there is a S between two nodes or not?
In a graph or in a
DFS tree, sir. DFS from DFS tree.
DFS tree. Okay, how to find there is a edge or not?
Yes.
Okay, but why you have to find that?
Sir, there are some questions I think have inactivity or practice assignment also. And I am not able to find
This
that.
from last week maths session.
See, listen. Some different questions are there related to this in maths. Let's not talk about that. I mean, I whatever you're saying, I think someone asked me in earlier sessions also. That math session is something which is different. You talk there. Over here, I don't think we have to find that there are existing ages or not. Only thing, if something is visited, you don't visit it again. If you remember the lecture which Madhavan sir took, he is maintaining one dictionary. Dictionary say, which stores all the vertices which are visited.
Okay, thank you.
Sir, I have one small query regarding this.
Okay.
In the right hand side, this output DFS tree, it is directional. Means arrow is there.
Okay. See, ideally, sometimes people write it like this, what I have written, or else you can put arrows also. Because tree is always directional. So it doesn't matter whether you put arrows or not, trees are always directional. This is a root node. This is a root node. This is first level, this particular thing. Second, this is first level. This 3 and 5. The 3 and 5 becomes your next level, and this is your last level. So you go from 1 to 2, 2 to 5, 5 to 4. But you can't go from 4 to 5 unless you are doing backtracking or something. But otherwise, the standard thing is you start with root and reach to the last node in particular path. You keep walk down the path.
Hello.
So it's not mandatory to have arrows over there because it's assumed that they are there. But you can always do arrows also. There is nothing.
So, sir, for an
and then
undirected graph, you are saying
guys,
that we can have.
listen. One person at a time. One person.
Sir, in reference to the same.
Finish. Yeah. Okay. Yeah.
Sir, in reference to the same.
During execution of this, that what you are showing, you have used 3 color. One is yellow, one is red, and another is ash.
Yeah.
What is the significance of that 3 colors?
See, that is just for example I took it. It's not necessary to use colors. I was trying to do something like this. So the current node is I used yellow and green are, whatever the greenish color what we have here is unvisited nodes. And neighbors I use some different color, something orange, yellow.
If you freeze. I understand. If this one is yellow and 2, 4 and 2, that means first one is visited, then one is explored.
Correct. You can't explore something unless and until you visit it. You don't know. See, currently at this point, your computer or your depth first search algorithm doesn't even know that 5 and 3 exist.
Yes.
Okay. So unless and until you come to know that they exist, you can't explore.
Sir.
Yeah.
Sir, if it is given if it is a multiple choice question, and if we have the DFS tree in which one starts with number 1 and the other starts with number 4 or 3 or any other number, but if the tree is correct, then should we select both the answers?
No, for depth first search, it always there is one thing which has to be given, which is starting vertex. So if you remember, this is the place where I started. It says starting vertex 1. If this is not given, you cannot even execute depth first search.
Oh, okay.
It should be given. Okay.
Sir, I have not completed my doubt. My main doubt is, sir, when I visited, then explored, but since this is a recursion process, as you shown in the previous slide, first you suspend the work, then go to the forward, then suspend that, then go forward, and while you are coming back, you are actually completing the whole thing.
Correct.
But here, sir, I observed you when one is explored, it is having 2 nodes, 2 and 4.
Correct.
When one move to 2, 2 is visited and 2 get explored by the you now completed the 1. This step I get a little confused, sir.
No, 1 is not yet completed.
But you mark it red, sir. That is.
Yeah, just because it's visited, right? Now we know 1 exists. That's why I marked it 1.
Acha.
Okay. That's what I'm saying. Forget about colors. Focused on the logic behind it. I mean, logic over here. Colors are there just to distinguish between different nodes. If you are getting confused with colors, forget about colors. Consider it as a plain black and white thing. Okay. If you understood this, whatever logic you are saying, right? We started with something, and when we come back, we are finishing what we left off initially. That's absolutely correct. That's recursion, and that's how depth first search works. So
yes, and when, sir,
understanding
you
is
have,
correct. Yeah.
When you are in note 5,
Yeah.
when you are in note 5, I thought since the 4 is get already means explode by 1, I thought
no, it's not explode. It's not explode.
Oh, it is.
This point, it was not explored. We had an option to explore either 2 or 4. We decided to explore 2. So 4 again became, if you see here, 4 again became like something not visited.
Okay, okay, got it, sir, got it.
But if it was a BFS, we would have done that, right?
It's a BFS, then it's a totally different ball game.
We would have visited both 2 and 4 in the first, when we finished.
Correct. We would have visited 2, 4 at the same level, then we would have been to next.
Because that means level wise searching.
Correct, it's level wise. To finish one breadth together, then only you go to next level. Over here, what happens? This is there in second level, right? Let's consider 1 in 0th level. Generally, we start with 0. So this is 0th level. This is first level. Then third level. We stuck at third level. That's why we went back and added in third level. But ideally, after third level, we are supposed to add fourth level. But fourth level was not possible. That's why we went back and added third level again. But again, from this third level, where we should go? We should go to fourth level. That's why we went to fourth level.
Okay. Question. So for an unstructured graph, the tree can be directed, or can it, or does it remain unstructured tree?
Hold on for a minute. Let me move that. Puneet, you are asking, right?
Yes, sir, if you don't mind.
Yeah. No, someone is there is a noise from someone saying. Right now, you only asked the question, or someone else?
Sir, I asked.
Aditya. Apul. Okay. And okay.
They were also asking. Like I stopped because they were asking basically.
Okay, so see, for everyone, whenever you talk, only for that fraction of time, you unmute yourself. Otherwise, please keep yourself on mute. If someone is talking, next to you at your home or someone, we are able to hear that also. So please make sure that.
Like I was mute only for that time. Okay.
Yeah. Okay. Yeah, Apul, go on. Apul, you asked something.
Sure, sir. Thank you. Yeah. Sure. For an unstructured graph, the tree is directed. For example, I'm just taking a hypothetical situation. We have been given an unstructured graph, undirected graph.
Okay.
Undirected graph, and there are 2 options of tree, where one of the trees shows a direction. For example, the same tree shows 1 to 2, there is a direction, and another option shows an undirected tree. So what will be correct? Both will be correct?
See, as I was explaining it to someone else, tree by default has a direction. There is no.
And that means.
Okay.
And that means
listen. Okay, with respect to graph, there is a difference as directed graph, undirected graph. With tree, you will never see directed tree and undirected tree. No, tree is tree. That's it.
Okay.
Okay, there is no concept of directed or undirected tree, because tree has a standard thing. You start with a root, you go down. So even though you give that arrow or not, it's assumed that arrow is always there. You can give it, you don't give it. It's always there.
Got it. Thank you. Thank you.
You cannot have arrow from 2 to 1.
No, I think what is being asked.
Excuse me, sir.
There are two options. One option with tree having.
It will not be given like that. If that's the case, both are equally correct. Both are equally correct.
Sir, what are we trying to achieve by using this algorithm?
Which one? Website search?
Yes, sir.
Okay. What?
Like my question is like, what is the purpose of doing this?
Gauri Agarwal, please keep yourself on mute. Yes, Afwan. What we are trying to achieve here?
Yes, sir. Like, are you trying to find out like how many nodes we can reach from a particular node? Is that
So
what you're
this
trying to do?
is something. This is something which is you. I mean, it has multiple applications. I will give you the simplest one. Okay. I mean, this is something which even professors covered in the lecture. How many places you can visit if you start from, let's say, place X without stopping, without getting stuck in between?
Okay, sir, I got it now. We can use the example that they did. Yes, sir. Yeah.
I mean, with respect to trained data set, if you consider like, right, I mean, there are some 4 lectures which talks about all applications of depth searching.
Yes, sir, I got it, sir. Yeah.
Yeah, sure. Thanks.
So can we
Okay.
please go to one activity question?
Shreya, today I will come. I mean, I don't mind, but today I will take it at last if the time permits. But
Okay,
today
it's
the activity
regarding
questions
graphs
is
and
not the
trees.
purpose.
So I
Still,
posted it to the
activity question of week 8,
Okay.
7, 8, 9. There is a separate session happened
Okay.
already. So I won't go there if unless it's something that becomes critical.
Okay.
Okay, Puneet, you are asking something. I missed you, I guess.
Thank you, sir. I have two simple questions.
Mhm.
The graph that is shown on the screen that you're doing DFS,
Yeah.
BFS goes level by level. So will it go 1, 4, or 1, 2, and 4, and then to 5? Because 5 looks as level 2 for me, the next level.
Yeah. So at root level, you will have that 0, 1. Below
Right.
1, you will have 2, 4.
Right. It'll be 2 and 4, right?
Yes, 2 and 4 at same level.
Okay. Okay. Then it'll be 5 and 3 after that.
After that, correct.
Right. Because we get so confused. We should go by level of connection, not by the level of the visual graph.
No,
So,
it's level of the
right.
connection. It's connection.
Yeah, a lot of us are making that mistake. We are going visually instead of the connections.
No, it's about the
Right.
connection only.
And so second one, there was a thing about in the mock test about distance. The shortest distance and the longest distance. That is told by BFS only, not by DFS, right?
Not exactly. I mean, when you talk about a distance, again, you have to be specific about what kind of a distance you're talking. Distance of a path or distance of something else. I mean, that's
Path.
something which is
Path
totally
distance.
a different thing, which we have
Okay.
not covered in computational.
You've not, okay. All right. Fair enough, sir.
Yeah.
Okay. I'm done.
Actually,
Thank you.
for shortest and longest distance kind of thing, there are different algorithms. Depth search or breadth search, BFS is not used for it. There are other algorithms. I don't want to give you those names.
No,
Otherwise,
we don't want to do that. Yeah,
yeah,
we don't.
exactly. I want to avoid that at least a day before your quiz. Maybe
Sure.
Monday I will give you names so that
I don't need answer. No, we were doing
Yeah.
it for something, and they were asking whether BFS can tell the number of edges between one to the other in CT itself in one of the lectures. So,
Okay.
sir mentioned that BFS can be used to tell how many edges away one node is from the other. DFS cannot. So that's
Okay,
why I was
number
asking.
of edges is a different thing. Distance is a different thing.
Distance is number of edges. Yes. How many hops away? Remember that question about hops?
Okay. Number of hops. No, that's fine. Again, I'm telling you that's different than distance. When you understand why I'm saying it, that okay, fine. What you say is correct. Let's close it with that. Yeah.
Okay. So BFS to tell number of hops, not DFS.
Correct.
Okay. Thank you, sir.
Yeah. Distance, something you will hear it again maybe later. Then you will realize why I stopped it here.
Okay. I think I'm opening Pandora's
That
box.
is
Okay.
totally
Sorry.
that is totally a whole different world when it comes to distances and algorithm and graphs.
Okay. I'll go to mute, sir. Thank you.
Yeah, sure. Thanks. So, yeah.
Sir,
Yes,
I
is
think
that?
we have to moved on week 8, sir. I have some doubts.
Yes. Great. That's what I was going to say. That we'll stop here. We'll go to previous week 7 and 8 now.
Sir, I had a question. My name is Aditya. Can I go ahead?
Yeah.
So, sir, actually, I had a question from week 9 itself. So, if maybe we can come back to week 9, you continue with week 8 and 7. Actually, you covered this question in one of your previous sessions, but I still have a doubt. It's actually from activity 9.2. There were 5 options of, the possible graphs, possible trees which can be generated. So, shall we come
Depth
back after
search,
you
right?
come?
Depth
Yes,
search only, right?
yes,
Okay.
yes,
So
yes.
let me
The
tell
same
you.
question I had actually.
Okay. With respect to that question, we have not considered that selection criteria of ascending order. If you remove that ascending order part, there are different possibilities of depth search trees. All those possibilities are covered in that question. So you forget about that, ascending order or alphabetical order selection. And if you have 2 or 3 neighbors, select anyone randomly. And then you will get different trees. So all those trees are there in that activity question.
Correct, sir. This explanation was also I have sought and I got it from one of the members in the discussion forum. But then
Correct.
that ways, it seems to me that all the 5 options are correct, and why option 2 and 3 are incorrect is something which I didn't understand.
Okay, if
So
that's the, I will come to that later. Okay.
sure.
That is
Thanks,
something which
thanks.
is very specific to that question. That is not a
Yes, yes.
general.
It is. I'm completely
I
okay with
got
that.
to know.
Yes.
I mean, I don't remember the vertex letters right now. Otherwise, I will tell you the answer also. Question number 2 and option 2 and 3 are incorrect, right?
It's quite, yes. Option 2 and 3 are incorrect.
We'll come to that at the end. Maybe in a 10 second or something.
No issues, sir. Thank you so
Fine.
much.
So we'll start with week content of week 7 and 8. Okay. So that's nothing but simple graph, adjacency matrix, then dictionary representation, and how to create a matrix in the first place in order to store. Yes.
Sir, my mic was not working. I have one doubt, and just very simple doubt. You said that in this DFS we can't find loops, but in video 9.2, sir showed us how to find loops using DFS. So
No, in
like
depth search tree there will not be a loop. That's a different thing. He was
no,
talking
but
about the
student number 8 called for 9, then 9 can mentor 3 more, then 13 can like going on further. Then there was a point where student number 13 can actually mentor 9, but 9 was already covered by 8. So then in 9.2 lecture it has happened. Then
So that
like the
was
sir
that
said
is
there is a group.
over there they were not explaining depth search. They are explaining something called as graph click. Something called as click. They are explaining there where each vertex is connected to every other vertex. So then that forms a click. So that's not a depth. I mean, they were trying to explain 2 concepts together. So maybe you watch that lecture again carefully for that click. Okay. You don't.
So
This is for sure that whatever I'm telling you. Okay. I don't remember what exactly what they use there, but tree will never have this particular cycle for sure. Yeah.
No, but we can't under any condition we can't use DFS to find loops right now. I just wanted an assurance right now.
Yes,
That's what
absolutely.
you meant.
Absolutely.
Okay. And I have one more doubt, and that is like I have seen some videos in which sir has told that if we have to start from one station and that I will land at one station, then I'll take some train, then I'll take some station. I hope you remember that part. So I was wondering that there we used DFS, but how in real life is that going to be useful? Because that is something which we shouldn't be doing, because we have done something similar in week 10 also, but I was wondering that why we are going on that.
Fine, that is something specific to that one example they have explained with those, hopping out of, coming out of one train, going to other and all that. But fine, I mean, if you have understood depth search concept, don't worry, you will go, the exam will go good for you. Don't worry about that specific example. Okay.
Thanks.
That's what I'm telling you guys. Please don't be concerned about specific example or specific question. Focus on the concept. If you know the concept, you will not face any problem in the exams. Concepts are more important. Okay, examples and questions are just there. but more you should focus more on concept. So we'll move to week 7 and 8, which is the initial part of a graph. Okay, so
Sir, in
this is.
Trio also we have random access.
Hey guys, I'm not taking any question. I will explain this, then I will take question. Don't disturb me in between now.
Okay, sir.
Everyone, please listen. Right now I'm going to do week 7 and 8 graph. So we will start with this. Okay, look at this particular graph. We will take this particular example, and I will try to explain how it goes with various transitions for this particular graph. Okay, so someone was asking earlier that whether should we consider this kind of a graph, or should we consider a matrix, or should we consider a dictionary. So in general, graphically or on using pen and paper, we can draw a graph like this with this number of vertices. These are directed edges, and every edge has some label. What that label represents right now, let's not go there. So there is a vertex edge labeled graph. Okay, directed, it's directed edge labeled graph. Okay, so this is something which we can easily draw on a using pen and paper. But how computer can store like something like this? It's not possible, right? Computer cannot store this. You can store it as an image or something, but computer should also able to process it using some algorithms, and algorithms execute only on data structures. So in our in our computational thinking, we have seen only two data structures, list and dictionary. So somehow we have to convert this graph into a data structure, then only algorithms can execute on it. Okay, so how to represent this graph into a adjacency matrix, or generally a matrix which represents a graph is called adjacency matrix. So if someone has a doubt what is the difference between adjacency matrix and a normal matrix, there is no difference. A matrix which represents a graph is called adjacency matrix. So it has 5 vertices, right? So that's why we added 5 rows and 5 columns starting from 0 to 4, 0 to 4. So for example, there is a age from 0 to 1. Just, give me a second. Yeah, sorry. So for example, let's take an example. There is a age from 4 to 3. Okay, there is age from 4 to 3. How will come to know, how computer will come to know that there is age from 4 to 3? Take, this is the starting node. Okay, this is the destination, starting and ending. So starting should be, you should look in row 4, 3. So this is 4, this is 3, you found 3. This means, so this means there is a particular age from 4 to 3, and label for that age is 3. That's how each age in this particular graph is represented over here. 1 to 2. There is a age from 1 to 2, label is 1. There is age from 1 to 2, label is 1. So this is how you convert a graph into a matrix. Still, matrix is like a still, I mean, it may not be as graphical like a graph, but still it's a table. You cannot store this table as it is using the current whatever data structures we have seen. Of course, matrix and those things are there, but in computer science, we do not have it. I mean, we have not seen it. So what we have seen it is, we have seen list and dictionary. So somehow we have to convert this particular matrix into a dictionary. So this is how it will be done. Convert this matrix into a dictionary. So if you try to compare this with this, try to compare this blue color dictionary with this matrix, it's exactly identical. It will look like. So whatever you have this on vertical rows, 0, 1, 2, 3, 4, they all become keys. This is the dictionary of dictionaries. So outer level dictionary keys are row numbers from 0 to 4. This particular entire row became inner dictionary.
Sorry, sir, there's a typo. Dictionary first row.
Okay.
4. 4 should be 1, right? After 4.
What? Which one? This one? No, 4 is 8. No.
Okay, so that we are storing direction steps.
Yeah,
We're not
I'm
storing
just
one.
coming there. Just
Okay.
call
Doesn't have any buttons or grades. It's big, but it's
okay. Who's that? Please keep yourself on mute with the CAB. Okay. So yeah, I don't think there is any typo, is it? No, right?
No, sir.
Yeah.
Shortage of understanding.
Excuse me, sir.
So yeah.
Excuse me, sir.
Yes.
Sir, in this type of problems, we will be using
See,
three loops.
listen,
I and K.
Prabhijit, I will come
Yes,
to
sir.
your questions. Let me cover the concept first. Okay. I will take questions on this. I will give you
Okay,
time.
fine, sir.
Okay? Yeah.
Fine, sir. Thank you.
Okay. So what we are doing is we are picking the entire row. Okay. One whole row we are picking 0, 3, 0, 0, 8. Constructed a dictionary out of it like this. Constructed a dictionary over here. This is your one row. And that one row can be used, access using this particular reference 0. So this particular 0 will be used to access the entire row. Now inside that row, we have to again decide based on column. That's what we did, right? When we said there is a age from 4 to 3, we went into 4 and we stopped at this column 3. That's we got 4, 3, we got this 3. Similarly, we went into 4. When we got that key 3, we stopped because we got that value 3. So this is the exact identical representation of a matrix to a dictionary. All your rows becomes your outer keys like this, and your these columns are nothing but inner keys. So these columns has to be replicated inside every dictionary. So you will see there is 0, 1, 2, 3, 4. Again 0, 1, 2, 3, 4. Again 0. So these columns are they are duplicated inside every dictionary. That's how we achieve this. Now, how you generally how you will access any particular age over here? Let's say this particular matrix name is again a matrix, okay, or M. How you will access this 4? You will access this 4 as M of 1, 3. Correct? M of 1, 3 will give you this 4. Same thing will happen over here. Matrix of 1 of 3 will give you 4. So that something is represented using this particular table. Matrix of matrix of 1 of 3 will give you 4. Same thing happens with dictionary. Same thing happens with this particular matrix structure. Same thing happens with the graph. So still these three are nothing but different representations of a same graph. This graph is a graphical representation. Then adjacency matrix of that graph is represented using a matrix structure. And then in order to compute it, in order to execute any algorithm on it, we converted into a data structure, which is a dictionary, which is a 2 levels of dictionary, it's a nested dictionary. I hope this is how the transition happened from one graph to matrix, matrix to dictionary. So here onwards, we will use this particular matrix for processing. That's what is there with a depth first search or any algorithm. This matrix will tell you whether there is a age or not. And if yes, age is there, then what is the value against it if it exists. If it's not, if this particular these ages do not have values, we will simply put 1010 as we have done earlier. Correct? So that's the
Did not understand the outer and inner values for the matrix. It's not clear.
okay. So this
Yes, sir.
particular outer key represents the row number, whereas inner key represents the column number. So how you will access, as I was saying, taking this example, how we will access this number 4 over here? How we will access this 4? Row number 1, column number 3, right? So outer key 1, inner key 3. Row 1, column 3. Outer key 1, inner key 3. Outer key 1, inner key 3, you got your value 4. That's how you will access any value in the given dictionary. Okay. Now, there is one more concept in addition to this, which is how to create a matrix in the first place. That create matrix procedure was there, right? This particular procedure, which Professor Madhavan Mukund explained, that excuse, for a given number of rows and given number of columns, how you will create a matrix with all zeros inside. So let's see how this particular thing works in general. How this matrix is constructed. I mean, this is something what we saw earlier may look easier with respect to, I mean, just conversion. But there has to be some program, right? There has to be some pseudocode which constructs the dictionary. So this particular pseudocode will construct a matrix, construct a dictionary with this number of rows and this number of columns. And values are always 0, as we have explained. Create matrix generates a matrix or a dictionary with all zeros. Okay. So let's see how it works.
Sir, is there any reason for using double equal to in the previous slide?
Yeah, because what is the difference between single equal to and double equal to?
Single equal to is assignment, double equal to is checking.
Checking. So that's what here I'm not assigning value 3 to this.
Okay.
This list tells that whether it's there or not. I mean, you consider it
whether it is 7 or not. Okay. Yeah.
Sir, can we consider in this graph rows to be incoming and columns to be outgoing?
No, it's not like that. See, it's always with respect to adjacency matrix, you always read adjacency matrix like this. From row to column. Every edge is from your row to column. Every edge is from row to column. That's why it's like that. Your row becomes your starting vertex, and your column tells you what is your destination vertex.
Okay.
Yeah.
So the thing will be the same for directed and undirected graph.
Yes, yes. But okay, I will come there. Okay, let's not the flow. Let's not break the flow of this. Okay, otherwise I will also forget what I was trying to explain. So what's happening here? We will construct this initially matrix with it's an empty dictionary. So as per first line, this will happen. Let's construct this particular, call this procedure with 5, 5. Okay. Let's see 5 number of rows, 5 number of columns. What happens as we go on executing this pseudocode? Initially, because of this first line, we constructed this particular matrix. So this matrix is just a variable. Okay. Matrix is a variable. Actually, because of this is a curly bracket, you know, it says it's a dictionary. So we are trying to build a dictionary which is a representation of a matrix, what we did in the previous slide. Okay. After this, I is equal to 0. We are checking this is the first loop. Then we are doing something like this. Matrix of I is equal to empty dictionary. What does this mean? We are creating a key I. Now I is a variable. What is the value of I? 0. So we are creating a key in the matrix called 0 and assigning a value to it which is a empty dictionary. So that will generate something like this. Why? Because I is 0. As I is 0, I is key got generated and value is an empty dictionary. Next thing, now j is equal to 0. Then inside this loop, what we are doing, matrix of I of j is equal to 0. Matrix of I means matrix of this 0. Inside that means inside this dictionary, we want to create j. Now j is 0. and assign value also 0. So this will create something like this. Matrix of I of j. Matrix of 0. Inside that there is another 0. This is your I. This is your j. And against that we have assigned value 0. That's why this 0 came. Similar thing will happen when j gets incremented. Right? Here we are doing j is equal to j plus 1. When we increment j, we are doing matrix of 0 of 1. 0, 1 is equal to 0. So this will generate something like this. 0, 1, 0, 2, 0, 3. So for against this, still I is still 0. I is not yet incremented. Outer loop is still the first outer loop is going on. Inside that outer loop, there is this particular inner loop. This inner loop will generate this particular inner dictionary. For 0, 0. For 1, again 0. For 2, 0. All setting, everything is getting set to 0. After this process, your j is not anymore equal less than columns. So this will stop the execution of while loop. It will increment I and your while loop execution will start again, the outer while loop. This will create matrix of I is equal to empty. Now I is 1. So it will create outer key which is 1 like this. It will create an outer key and again because of this inner while loop, it will create this inner dictionary. Same thing will happen with when I becomes 3, this will happen. Sorry, I becomes 2, this will happen. When I becomes 3, this will happen. And when I becomes 4, this will happen. And that's the place your outer loop also stops. And you return created matrix back where this create matrix procedure was called using 5. So even though the variable name is matrix, actually it is a nested dictionary, dictionary of dictionaries. Same thing again, outer key represents a row, inner key represents a column. Then as per your requirement, you change the values. Now you later on you came to know that there is a age from 2 to 3. So as you came to know there is a age from 2 to 3, this 0 has to be changed. This 0 you will change to 1. This will become 0 to 1. What does this say? There is a age from 2 to 3. That's why we made it 1.
If that
Similarly,
edge is labeled 0?
If it's okay, if the age is labeled,
As
age is
0?
labeled, see, age will not be labeled as 0 because most of the time ages are labeled for some specific reason, right? Generally, ages represent the distances. Distance cannot be 0 between two different vertices. So
Okay.
it will be a positive number.
Okay.
Yeah. So that if it's an age labeled graph like what we saw earlier, then that specific age, let's say some 7, then that age will come. Instead of 0, it will come 7. If it's an age labeled graph, but there is no label, then just to say there is a connection, we will put 1. That's how this particular matrix can be used in order to store a data as we want. But initially,
Here,
this is
if
how.
we, sir, if we
Hold on,
here
hold on, hold on, hold on, hold on. Initially, this is how the matrix will be created. Later on, we can move this particular matrix as we want, and we can change these zeros to whatever values we want based on the connections, based on the values against labels, and so on. Okay, just give me a second. See what's next. It is the last one. Yeah, okay, fine. So now we will take questions from this. Yeah, someone was saying.
and that I asked. The 3 inside the dictionary of 2 here tells that there is an edge from 2 to 3, and 0 tells that it does not have any value. It doesn't store any value currently.
See, currently when you don't have this thing, what this thing says that right now we have just created an empty dictionary which is not representing any graph. This particular thing is not representing any graph. This is just one, what we say, a blank template we have created. It's a blank template we created. This template we will use in order to store some graph. Then we will go through that graph and accordingly we will update those values over here. So this is that blank template. Now, later on we came to know that there is a, so with respect to our trained data set, this is where we started. Okay. Then we came to know that there is a direct train. We went through our data set. We went through our station cards and those train cards and so on. We came to know that station 1 has a direct train from 1 to 4. Okay, there is station 1, there is station 4, and they have a direct train. So that says 1 to 4, this should be converted to 1. This will become 1. Now, as you know, our train data set, how they are. If there is a train from 1 to 4, definitely there will be a train from 4 to 1. So that will make this entry also to 1. Then likewise, we will keep going. Every new card will make one of this 0 to 1. One of this 0 will be converted to 1 whenever we see a new train. New train means what? There is a direct train from station A to B. So whenever there is a train from, let's say, some station A to B, that has to be reflected into this dictionary against those values A and B. For example, A is 4 and B is 3. So A is 4, B is 3, you will make this one because there is a direct train from 4 to 3. And so on. So as we go on going through our data sets, we will modify this. But as you know, every variable should have some initial value. So this is your initial value. Initial value for that particular dictionary. You will begin with this. Then you will modify the values as you go on executing the pseudocode. Yeah. Any other question?
Yes, sir, Puneet. Why do we
Okay.
need rows and columns? Why not only n? Why not only one of them? It's always a
Okay.
square, right?
So yeah, it's not necessary. It will always be a square matrix, right?
Oh, that's what we studied, na? N square, n into n minus 1. So we'll have to forget that.
Which one? Which one you are saying? Can you?
Sir told us that the number of rows and columns, total number of positions is n square. Number of connections is n into n minus 1.
Correct. Correct. Yes.
So the concept is that we're only dealing with squares. That whatever is on the rows, same thing will be in the columns.
Okay. With respect to adjacency matrix, that's how it will be. Correct. But that's not necessary that always matrix will be of. It will not necessary that it will always be a square matrix.
Okay. So it's possible. It's not square.
Adjacency matrix will be always square because every node which appears on the rows side, which should appear on column side also. Then only connection can be made.
Right.
But
right.
every matrix cannot be a square matrix.
No, not
right?
every, we are talking about this create adjacency matrix, right?
Correct,
this is
correct.
Okay. Thank you, sir.
Yeah. Okay. Just hold on for a second.
On this,
also there is.
you have told the depth first search. You told that.
Hey, listen. Hold on for a second. Give me a minute. I will give you a chance. Just hold on. Okay. So sorry. Yeah, continue. You are asking something.
You have told for depth first search we make a dictionary. Okay. So basically, this how they're also like which we were making a tree. Okay. So for tree, how we are representing it, if you can just tell, like for a dictionary wise.
Okay. So in that tree, there was a connection from 1 to 2, right?
Yes, it was.
Asking? Yeah, there was, if I remember correctly, there was a connection from 1 to 2. Okay. Can you see this one also, DFS tree also? Yeah. So to represent this connection from 1 to 2, how you will represent here? There is a connection from 1 to 2. So this will become 1. This will become 1. After that, over here, after that, there is a connection from 2 to 3. There is a connection from 2 to 3. How the 2 to 3 will come? This will become 1. Then there is a connection from 2 to 5. How, what 2 to 5 means? Now, right now we don't have 5. So if just assume if there is a 5 over here, if you have 5 over here, that 5 colon will become 1. We don't have 0 here. So we'll just try to understand relative. Okay. From 5, you have 4. So from 5, you will have that 4 over here, and that will become your 1. So likewise, you can store even a tree using this. A tree is nothing but a sub graph. Okay. A subset of a graph is a tree. So if we can store the whole graph,
I think
definitely
we are going
subset
wrong.
can be stored. Yes?
Sir, in graph, we are starting at 1, 2, 3, 4, 5, 6, and in dictionary, we are starting at 0, 1, 2, 3, 4.
See, that is for an example. Okay. This is just a label over here. These are the labels given. It's not necessary. We can start, instead of this, I can have ABCD also. But dictionary keys, this is how the code is written. This is the procedure which is Madhavan sir had explained. So over here, we are starting with 0. And let me tell you, I think I have told this many times earlier, in computer systems, everything starts from 0. There is no 1, 2, 3. It's always 0, 1, 2, 3. That's how computer systems work. Any digital device works like that.
Sir,
Okay.
I have a question.
Yeah.
Sir, while forming matrix, when we are done with j is equal to j plus 1 and I is equal to I plus 1, then we got value of I is equal to 1, right? Then we
Yes.
move to the next row, I equal to 1. Then again in procedure, matrix I equal to 0 here. So if get the value I is equal to 1, then why we are starting with again I is equal to 0?
I is equal to 0, we did only once.
Okay.
After incrementation, we will start from this line, right? This line will not execute again. We did I is equal to I plus 1. After that, we came to this closing bracket. What does closing bracket says? Go back where the loop started. Where loop started? Over here. So this is
Okay,
our
sir,
loop.
I got this.
This will not
In
execute again and again.
Okay, in second line, that 0 is belongs to j for j equal to 0. That is column, right?
Yes, that j is equal to 0. That we required, right?
Okay. Okay, thank you.
Yeah. Yes, anyone else?
Sir, depth first search function, which we generally in the graded assignment and DFS function was there, used many times. So whenever DFS function is used, we are just expected to create an adjacency list, adjacency dictionary.
No, see, we never use, we have never explicitly mentioned how DFS function is. In an assignment, DFS function is used many times, but over there, DFS function pseudocode is given in the question itself.
Okay.
So you should follow that pseudocode.
It will
See,
always be
create matrix is a procedure which professor mentioned, and we have standardized it. Whereas other codes will be always given. So if some DFS procedure comes into your exam, you have to follow that code. Only for this create matrix, you assume at the end you get at the end of execution, you will get a dictionary like this. This is something which we have standardized, that create matrix creates a matrix of size rows into columns with all zeros inside. Beyond that, we have not standardized any other DFS or BFS procedures. For those, there will be code given and you have to follow the logic of that pseudocode. Okay, anything else?
Sir, in the when we make tree, there is random access, or we have to move it step by step?
In a dictionary?
No, in tree. FS
In
tree.
tree.
Yes.
Okay. See, tree is ultimately, it depends on how you store a tree. If you're storing a tree in a dictionary, always random access will be there because dictionary has a random access. See, tree or graph has a, I mean, whether a tree or graph has random access or not, that's not the question. It's about how they are stored using the data structure. If the data structure allows a random access, then the random access is there. If data structures doesn't allow it, then it will not be there. So in this case, our graph entry, if you are storing using the dictionary like this, see now this particular graph is stored using a dictionary. So as a dictionary has a direct access, yes, you can have a direct access for a graph. If you use some other mechanism to store a graph and that mechanism doesn't allow random access, then for that graph you will not have random access. So it depends on
Yeah,
data
so for example,
structure.
you used a list, right? So that doesn't have, you just had a list also.
Correct,
Pages of
correct.
list. That doesn't
Then
allow.
random access will not be there.
Okay, sir. Yes, sir.
Yeah.
Got
So,
it.
but that's mean, I mean, dictionary don't have any sequence or order. So, like, you
Correct.
don't know
If you
exactly what's
use
the order of the keys, right?
correct, correct. If you do not use if you don't use dictionary and instead of dictionary if you use list, this whole table you cannot generate because list doesn't allow you to do one of two. You have to do for each kind of a thing. You have to write those nested for each loops in order to access this one. You cannot do matrix of one of two. It will not give you one. This is
Okay,
wrong.
so
With
like
respect
if
to
I
list,
want
this
to
is
just
wrong.
print the keys of matrix, so there will be no specific order in which it is going to occur, right?
Correct, correct. So, by the way, we have reached the time, but that's something I will quickly cover and then we'll stop. Anyway, by the way, whatever slides I'm using, right? Let me switch. Can you see your portal? Okay, this week 12, okay, you don't consider it week 12. This is something which is very useful. This is tutorial on pseudocode for fundamentals of programming. It covers week 1 to 4. This one, this tutorial 12.2, it covers week 5 and 6. This is the 12.3 tutorial which I just explained. So if you look at it, this is the same thing I was explaining. This is something what I explained earlier. So this is the same thing. So if you watch these 4 tutorials, it will cover week 1 to 9.
Sir, I watched all these videos. There's one question I have about one of them. Can I
Yeah.
ask you, sir?
On?
Okay. I think it is there is one table that you prepared. That first of L,
Yes,
last of
yes,
L.
yes, yes.
And before that, there was one appending of list and
Correct.
that yeah. So
Correct. Let me
that will,
open that. Let me open
yeah,
that
I think
because
it was a
many people
wonderful
ask
page what
for.
you have.
Yes, yes. So for that PPT, I will not go into depth because list and dictionary is from the previous week. But yeah, I will just take your questions directly.
Yeah, you need not go through that, sir. Just
Yeah.
I will ask my question.
This one,
Sir,
right?
can you just hold here? Can you just hold here on this
Yeah,
slide?
yeah,
If you
yeah.
see extend here, everywhere I understand for appending the list or for extending the list, we have to add plus plus. But
Correct.
but thereafter, why do you have two equal to signs? Because I understood two equal to signs is for checking whether it is equal to
Correct.
with so should I read it as one equal to sign, or it's correctly given as two equal to signs here?
No, it is given intentionally. There is no typo or anything. I will tell
Okay.
you what is the difference of the what does this mean? I'm assigning this value to this variable.
Correct.
If I give single equal to here, what will it say? I am assigning this value to this variable, but this is not a variable.
Okay.
That's why I've used equal.
Okay,
Sir,
understood.
can we please revisit activity 9.2 last question?
Sir, just
Yeah.
okay, sir.
See,
Just before
activity
you go there, sir.
question is something I will not go there because anyway we have run out of time.
Sir, there
If
was
you have
there
any
was a table
specific
that you created.
conceptual doubt, tell me about that.
There was one table that you created about that last of L and first. So this one.
Yes.
Sir, in this row number 1, 2, 3, 4, 5. Row number 5, which is the list
This
that you
one.
have. 2B. Yeah. So
Yeah.
there, first of L and last of L. Is it a typo or have I got it wrong? First of L should be 2, right? And last of L should be A, right?
Yeah. Sorry. This is the type.
Yeah.
This is the type.
Yeah. Okay. But this is a very good table, sir.
It should be
Help us
2
to
and
learn.
C. It should be 2 and C.
Yeah.
C, sorry, 2 and A.
Thank you very much, sir. No more questions from me, sir.
Sir,
Sir, I
I'm
have
having
a
a lot of difficulty with the clicks.
Yes.
So I'm having a lot of difficulty with clicks.
Okay, then tell me your question. I can't explain the entire list. That is from previous quiz. I can't go back like that. I mean, tomorrow you will ask me what is variable. I can't do that at this point.
It was in week 7.
No, list is week 5.
So it's not list, it's a click.
What?
I think he's saying click.
Yeah, he might be referring to click as in graphs. Clicks in
Okay, if
graphs.
you are talking about a click, then click is something where every vertex, every node is has a direct edge with every other node. Then it becomes a click. So, for example, so this is a click. Okay, why? Because there are 3 nodes and all 3 nodes are connected to each other directly. So this is a click of size 3. Okay, this is a click of size 3.
Okay, sir.
Your voice is breaking. I can't hear you.
Sir, I got it.
Okay.
This is a click.
Yes, this is a click. Okay. So any other?
Sir, one question. Sir.
Yeah.
Sir, if the list does not preserve the ordering, how is this first and last work?
No, list preserves ordering. Ordering is not there with dictionary. List has strict order.
Because it graded assignment 9, the 9th question, it was said cannot be determined, that order. There was a question there.
See,
Can you quickly explain, please? It's a small question.
Yes, because dictionary was returning it.
No, they converted it to a list.
List is the output. Input was a dictionary.
Okay.
So that is keys function.
Correct. So the keys will not preserve the ordering, is it?
See, keys of D. This is still a dictionary. D is a dictionary. Take this example. If D is a dictionary, then keys of D can return any of this.
In any order. I'm not able to see any screen here, but yeah.
Oh, okay. I'm sorry. Stop sharing from there.
In that question, okay.
Okay. So D is a dictionary.
Okay.
Keys of D can return output in any of this.
Okay.
Either is the correct value. That's why we cannot determine.
Okay, that is why
which
in that
exactly
question
will
it
be
said
required.
cannot be determined. That is the answer.
Yeah, because we cannot say whether output will be this or this or this. It can be anything.
Okay.
Yeah. It will have A, B, C. These three keys will be there inside, but in which order, that cannot be determined.
Okay. Okay. Okay.
Because that is how this keys function work. It's not
Okay.
about list.
Okay. Okay.
Yeah.
Thanks.
Can I ask the question?
So
Start of lecture?
guys, hold on. Listen.
So this
So I
slide
would.
is in week 12 video. In this particular
Yes.
slide.
So that's what I was telling you guys earlier. I
Okay.
think it's best if you go through those 4 videos before your exam. It will be very helpful. I'm sure about it.
Thank you so much.
Go through those 4 videos before your exam.
Okay.
It will
Sir, the
help
PDF is
you
posted
immensely.
anywhere?
Sir, which
I
4
saw only the
videos?
video.
Sorry?
Week
Yes,
12.
I will again
PDF
share
is...
it. Week 12. See, week
Okay,
12
sir, thanks.
has this tutorial 12.1, tutorial 12.2, 3 and 4. This is week, actually there is an announcement also regarding this. I think you missed this announcement. These week 12 lectures tutorials will be helpful for preparation of quiz 3 which is scheduled on so and so. The tutorial covers 1 to 4, 5 and 6, 7 and 8 and 9. So refer this one sec. If you don't have time to watch entire tutorial, then you can even do something like you at least go through the slides. So all slides are also available.
Okay.
So those same slides, whatever I was I used right now, right? Same slides are available. So this is the slide what we were talking right now. This was the same slide. Yeah, but still the typo is there. I mean that's something I will correct it, but for now you can refer it as it is. Okay? So all these slides are there from all those tutorials. I mean whatever slides I just tried to explain using the slides. So if you can't find time to go through the tutorials, at least go through the slides. It will definitely help you. I'm sure.
Excuse me, sir.
Yeah. Yes.
Sir, I asked the question in starting of lecture that what is the meaning of init inside init?
Okay.
Can you please
What?
explain?
Yeah. What init do?
Init
What
inside
init
init,
do?
sir.
Yes. Yes. Tell me what is the meaning of init in the first place?
Init mean except last element.
Okay, so let's take this particular example. This particular example, third line, 1, 2, 3, 4. Okay. You came to init. What is the init of 1, 2, 3, 4?
1, 2, 3, sir.
1, 2, 3. Now you give this as an input to another init. Then what will be the output of init of 1, 2, 3?
1, 2, sir.
Right. So that's your answer.
Wait.
Got it?
Okay, sir. Yes,
Yeah.
sir. Yes, sir.
Yes.
Sir, can you please explain exit loop once?
Yeah.
Yeah, so
If you want, there is an example in activity 7,
No, not
week 7.
Not needed. That's also that's something there in tutorial 12.1. Last slide is all about that difference between
Exit loop.
exit loop and return.
Okay.
That's
No,
why I'm
sir, I
telling
just
you
want to
watch
ask you
this
if
tutorials.
okay,
Yeah, I
sir,
will
I just
explain
want to
what is
ask if
exit loop.
there is an exit loop, where does it like exit? Does it comes directly to the end, or it's just coming out
No.
of that, like which loop? How to identify? Like
Yeah.
I get
Whenever there
confused.
is an exit loop like this, it only exits from the loop inside which that statement is. It will only stop this while loop. While j is less than n, only this loop will stop. Outer loop will continue. So if
Sir,
you
but
look
why
at this
not it
table,
comes out to if? So what is the rule? Like, I mean, if we apply exit loop, then it just comes out of if and
no. Whenever you apply exit loop, right, it jumps to the first closing bracket of a loop. It jumps to this point.
Okay,
Jumps.
okay. So the bracket which is just after the exit loop will not be counted here because that will not make sense. So
That
you're
is
saying
no. This is if.
ah,
This is if bracket.
this is if.
The
Okay.
first closing bracket of a loop.
Okay, so if is okay, I get it now. Like while is a loop and okay, okay.
It comes
Like
out of
More
the
technical question,
innermost
sir.
loop.
That,
Yes.
sir, I have gone through the week 7, 8, 9 and I have thoroughly understood it. And the week 12 just came. I just saw the email in the morning that it is a part of the quiz 3. So if we haven't seen the videos of quiz 3 of
Hey
the week
guys,
12, then would that affect it in any way?
Priyanshu, week 12 is not part of quiz 3. Don't
No,
misunderstand
I'm
what I'm
understood.
saying.
Yes, sir.
I'm not teaching you anything new. All these are concepts. This is like a summary thing. This will help
So that's
you
what I'm
prepare.
saying. That's what I'm
Yeah.
saying. If I haven't seen the lecture of week 12, that wouldn't affect me if I have understood the concept. There
Yes.
isn't anything new.
Yes. If you have understood, then it will not affect. But still, I would suggest for a revision purpose, you better go through it. If something you have missed, these slides will cover that. Those things.
And the questions are also new.
Questions are?
Are there any questions to be practiced?
No, there are no questions over here. There are no questions. I've just covered some topics, basic topics. Okay. So if you look at this, I have just explained what is if, what is if else,
Sir.
what is this, what is
Sir,
nested
please
if
tell.
else and those kind of things.
Okay.
Some basic
me,
things.
sir.
If you have not understood, it will help you. Yes,
Excuse me,
someone
sir.
is talking.
Sir, please will you
Sir,
explain
hopping.
about the nested loops if there are more than 2 loops?
Okay.
Sir, hopping, please.
Sir, please, if you can explain about the nested loops if there are more than 2 loops.
Okay, see, loops is something which is from week 4. I can't spend so much time doing this. Okay, it's already 8:20. I have to stop this session at some point.
3 loops.
See, I have to stop this session at some point. Tomorrow you have exam. Do your own study and go for exam. Okay?
Sir, please tell what is hopping. Like when we go from one node to another node, that is direct path from any node to another node is called hopping or something.
No,
like
it's hop.
if there is
Hop is something when you don't have a direct path. You can't go from A to Z directly. You have to take something
Yes,
in
sir.
between. Then that something in between becomes your hop. There is no
like
direct,
if there is
there is
if
Sir,
no
what
there
is
direct, there is no direct train from, let's say, from Mumbai to Delhi you are traveling. There is, for example, there is no direct train from Mumbai to Delhi. But there is a train from, let's say, Mumbai to Indore and Indore to Delhi. Then Indore becomes a hop in between. So that's the place where you change the train. You go from
Sir,
Mumbai
we
to,
did here one hopping.
yes, one hop, correct.
Yes, sir.
Okay,
Sir,
sir.
In the quiz, it was
Week 12
written that we
lectures
have
are
to
1
follow
to
the
4.
tables. The table that are provided to us, the data set, like the score data set or the any data set that is provided to us. We have to accordingly solve the questions.
Yes, correct. But you will not
So
require any table for your quiz 3.
yeah, I understood that, sir. But many questions are there where it is in the solution. It is written that if the two students have same marks in all subjects, and they have given that part in the solution, but there isn't any value in the table like that. So how do we have to solve it? Whether we have to consider it or not?
Yeah, you can assume, right? See, that data set, whatever data sets are given to you, that's for your understanding. We have not said that all questions are based on those data sets. We have taken reference of it. I mean, just the column names we are referring. We are not saying everything should not be based on those 30 students. Whenever we write a code, whenever we write a pseudo code, it's not specific to a data. If tomorrow some new students come, their marks changes, what you will do? Will you change your pseudocode? No. Data will always keep changing. Pseudocode should never change. So
When we solve
pseudocode
the
should
question,
remain.
when
You have
solve
to
the question, we
assume
have to
all
take
possibilities.
the
All possibilities.
general code.
Yes, you should consider all possibilities.
Sir, can you say something about side effects? That's the only thing which I have some doubts on.
Side effect is as in something for any given procedure, you give something as an input, and at the end of execution of procedure, your input changes. Then that's a side effect. You gave some a list or a dictionary as an input. When procedure terminates, original values of list or a dictionary are changed
Unintentionally.
in any way. Then that's a side effect.
Meaning not as a part of our program. Unintentionally it changes.
No, in any way, if they change, then that's a side effect. Sometimes side effect is expected, sometimes it's unexpected.
Meaning I decide to change it by writing a code, or does it change automatically? For example, if you move cards from one table to another, the order will be reversed. Those kind of things you are saying? Or?
So that's something you already assumed, right, that it will happen.
Okay.
So still side effect is there, but that is accepted side effect. That's something we assume that side effect will be there.
Okay.
Yeah. Then that's okay. Yeah.
Yeah.
Okay, so I'm stopping this session now. It's already 8:25. So I've tried to answer most of the questions. I know I've still skipped or missed many, but otherwise I will not be able to end this session even till tomorrow 2 p.m. So that I can't do that. So we'll stop this session. All the best, everyone.
Thank
Write
you,
your
sir. So,
papers.
Omkar sir, can I just have one note, please? Not a question.
See, if that's what I was talking about, right? I will continue till 2 p.m. tomorrow.
No. Sorry, sir. It's for others. So I'm just saying from my experience. I used to. I mean, so I feel that a lot of people are not writing the code and practicing, right? And if you do not do that, I don't think